so covalent bonding we're going to talk about today. Non-metal, non-metal. Guess what non-metals are? They don't include metals. No metals whatsoever. So this whole section right here that I just outlined, this whole part, those are all metals. We are not including them in this. We're talking about hydrogen, and everything above that stair-step line is a non-metal. Here's another thing. Noble gases, they don't bond, so you can exclude them too. So everything you're looking at here is the halogens and the little section up here with the hydrogen. These guys are going to be the guys that are going to be bonding. So do remember, no metals whatsoever. That means no charges. So we can get actually a covalent compound this huge. So here's the thing that you do need to write down. As you look at these Greek prefixes, we only use these for naming. You need to know each one of these, up to 10. I'm not going to give you anything over 10. Yes, there is numbers over 10, but we're only going to go up to 10. So you need to know mono, di, tri, tetra, penta, hexa, hepta, octa, nona, deca. The ones people do not know is 4 and 9, tetra and nona. And it's really weird how people remember some of these. Now I told y'all, the old Greek and Roman calendar used to be just 10 months, and this is how they named them. Mono, di, tri, all the way up to all these guys. Now over time they have changed it. They named them after gods and things like that. But if you take a look back at the old calendar before they added July and August at the end, because of Augustus and Julius Caesar, and normally it actually fell in line as soon as you got to hepta here. We're in the month of September right now. We're about to move to October. September used to be the 7th month out of the year, hence the name. That you can kind of see where September and hepta kind of actually coincide. Septa, hepta. Next month is October, octa. Next month after that, November, nona, and then December, deca. So it used to actually be named after the numbers, and over time it has changed. I know, mind blown. If you want to help remember tetra, we already did tetrahedral, but we also talked about tetris. So how we use these guys? Well, whatever the subscript is on a covalent compound, that's the prefix you use. That's it. That's the only difference. Notice we still add IDE to the second guy. The only thing we do not crisscross, we just do the other thing over there, which is actually just put the prefix. That's it. Okay. So try these out real fast. Remember, there is one little special note, and I apologize. The first name, we don't ever use the word mono on the first name, but we do use mono on the second. The second guy will always get a prefix. The first guy will not receive the mono prefix, but will receive any other prefix after that. So for example, we don't say mononitrogen dioxide. We say nitrogen dioxide. Does that make sense? That's what that little note up there means. So notice this. Whatever the prefix or whatever the subscript is, that is the prefix. Now keep in mind, there's no crisscross. There's no ions. There's no metals in this. These are all nonmetals. They're on the same side of the periodic table except for hydrogen. Hydrogen should be over there, but he's a nonmetal. As you look through each one of these, whatever the prefix is, that's what you put in front. That's what you're like, well, how do I go back from the name to the formula then? Well, they tell you how many pieces. That is the easiest part. You don't have to crisscross. You don't have to do any math. You just got to count. Nitrogen dioxide, 1 nitrogen, 2 oxygens. Boom, you're done. The next one that you see up there is dinitrogen tetroxide. Now notice that we did not put mono for nitrogen up here. Remember, we do not put mono for anything in the front. We do have to write mono for the second guy. The second guy in a covalent compound always has to have a prefix, no matter what. So you notice that all the second guys had to have a prefix. The only reason why we didn't write one for these guys is because they're 1. But anything higher than 1, we got to write it. So whenever I say dinitrogen tetroxide, you basically got to be able to go forwards and backwards between this. Well, it's easy. Di, 2 nitrogens, tetra, 4 oxygens. Boom. No crisscross, no nothing like that. Don't have to overthink these. They're exactly as they are. That's one reason why these are actually easier than all the others. The only problem you got to have is know those prefixes, but those prefixes are pretty straightforward. So do remember this little note right here. I did pop it up just now. Covalent compounds do not use the crisscross method. Do these form charges? Do you see a charge? No. No, you do not see a charge. All right, metallic bonding. We're going to actually cover this really, really fast. We're wrapping it up, actually. Metals form alloys. So we do not have a naming scheme for these guys. You do not have to know, I'm just giving you examples here. We just call them the word alloy. Whatever the metal's in, we just put the word alloy with it. That's it. So there's no crisscross here. There's no prefixes. It's just the word alloy. Boom. We're done with that. All right, so you're going to get a chart like this to kind of help you out tomorrow, but we're going to wrap up what we need to kind of finish up today. There's two big notes that we got to talk about. One is going to be what are the properties of ionic and covalent bonds versus these two guys. Then the last thing we're going to talk about is formula mass, and that's actually going back to your periodic table. So you're going to need your periodic table after this next little part. Okay, so ionic bonding is metal plus nonmetal, and covalent is nonmetal nonmetal. Here's the properties, and what I mean by properties, I mean like physical kind of properties. These are all physical, if you'll take a close look. First off, let's actually compare and contrast the two. This is a compare and contrast thing. How are they different? Ionic bondings have high melting points, okay? Think of two examples here. An ionic bond, the most simplest one we can think of is salt, right? We use that all the time. NaCl? Okay. Have you ever tried melting it like in a pan? Yeah. You might not want to.
Never done that.
Like without water. If you do that, it has a very high melting point. You couldn't do it on your stove. You have to have something very hard and concentrated to get it really, really hot. However, if you do ice or water, does it eventually boil or melt? Yeah, so it has actually a low melting point. It also has a low boiling point, which means it's going to boil faster. Ionic bonding, if you can actually get it to the melting point, if you can actually try to even get it to boil, it's going to be even higher. So these are two different properties right here. All right? Crystalline solid basically means it forms a crystal, which I did show you a picture of a salt in magnification. It looks like little boxes. That's a crystalline solid, even though it doesn't look like a crystal. So basically I'm saying ionic compounds are usually solid. Covalent compounds are usually to be all three properties, mostly liquid and gases, but sometimes they can be solid. Conducts electricity very well, but has to be in ion form. In other words, if you try to put up electricity up to salt, it won't conduct. But if you melted it or put it in solution, like dissolved in water, it does conduct electricity. One reason why you guys get electrocuted in water is because you are composed of salt. You have salt in your body. Water does not conduct electricity. What? But in the movies, people get electrocuted when they're in the water. It's because of salt in your body. You're the conductor, not water. There are ions in the water. Here's the thing. Does water have a charge? No, it's covalent. Salt does. That's why you get electrocuted. It's because of those sodium ions. They have a positive charge. What charge is electricity? Negative. That's why you get electrocuted. Mostly soluble in water, mostly insoluble. Have you ever tried dissolving oil in water?
It don't.
It don't happen. And believe it or not, oil is covalent. Yes, water is covalent also, but just because they're both covalent doesn't mean they're going to dissolve in each other. So, but most of the time, ionic compounds will dissolve in water. Mostly. All right, so formula mass. This is the last thing we got to talk about in this unit. Remember when the little mass number on the periodic table? If you haven't got your periodic table out, you need to find it. They have the mass number, or the average mass number. Well, basically all you're doing here is you're taking how many pieces and you're adding them together.
Trick.
There's no tricks here. It's really just basic math. So add these guys up and that's all you got to do. Now there is a quicker way of doing this. You could take, I'd put everything in my calculator, but do write down everything to actually add them up. But there is a few curveballs I could throw at you. Now here's a few of these. Quick question for you down here though. What? If there's a 3 out here, what's your instinct tell you from algebra class what you need to do in terms of finding how many pieces you have? Does that 3 just mean 3 carbons?
No.
So, remember foil?
Yeah.
Okay, well it's like foil, but basically you distribute the 3 amongst the C and amongst the O. So, how many C's do you have technically in this whole compound? 3. Now here's a good one. How many oxygens? 9. A lot of people want to say 6, but remember you're multiplying. 3 times 1 is 3, 3 times 3 is 9. So you have 2 irons, 3 carbons, and 9 oxygens. All right, let's go ahead and check these out. It says compute the mass of the following compounds, round to the nearest hundredth, which is 2 decimals, and name the type of bond. So on the first one, what is the mass? Oh, better yet, let's go ahead and ask this. What type of bond is NaCl?
Here's covalent.
It is ionic. Metal plus nonmetal is ionic. If you put non-metal, you need to go back and study. But anyway, as you go through, if you were to add up that, I took the masses off your periodic table. Hopefully they should be close. Sodium's mass is 22.99. Chlorine's mass is 35.45. You add them together, you get 58.44. And notice that the units are in AMU. We're still keeping the AMU. That will change later, but right now you just need to add them up. And yeah, it's an ionic bond. The second one, you had 2 carbons multiplied by 2, 12.01 times, or plus 12.01 is 24.02. 6 hydrogens, each one is 1.01 times 6, that's 6.06. Add them together, you get 30.08. Where am I getting these numbers from? The periodic table. And also, is this a covalent compound? Yes. Non-metal, non-metal. Okay. Last one at the very bottom, is it covalent or ionic? Ask yourself this, is a metal involved?
Yeah.
If yes, then it is an ionic bond. So, how I did this one, there's many ways you could do this one, but I did this like drawn out algebra way. First off, I did break it down in steps. There are 2 irons, each have a mass of 55.85. So I multiply those by 2. Notice I distributed this 3 amongst the carbon and the oxygen. That's where this 3 comes from, is this 3 right here. 12.01 is the mass of carbon, and there are also 3 oxygens. So I went ahead and multiplied those by 3. Now you could have done this. You could have done 3 times that, 3 times this, and then multiplied them all. That's fine. But this is just showing you my math of how it worked out in one little line. Then you should have got over 291.73 AMU. This skill right here is going to be essential for the rest of the year. It's one of the easier ones, but you got to know how to add these things up properly. You need to know also how to distribute the property. A lot of people just forget about some numbers and they move on. No kidding. All right, so notice what I've done. I've gone back and I've actually covered up all these answers. Yes, you should. So anyway, what is the name of the following compound, CO2? We already kind of did this one. First off, ask yourself the question, ionic or covalent?
Yeah.
So, non-metal, non-metal. Therefore, it's going to be covalent. Now, yes, you've already seen this one in the little practice, but it was supposed to be a quick little rundown. All right, So, non-metal, non-metal, that's going to be covalent. So, we got to do the prefixes with each one of these. Does the first guy get a prefix?
No.
No. Now, he does if it is more than 1. But since he is only 1, you just say his name, which is just carbon. Okay. The next one, if there's 2 oxygens, what's the prefix? Di. And then you just finish out with the regular thing, oxide. So which one was that? B. Even though I should have lowercase that one. All right, next one. What is the formula for the compound dicarbon hexoxide? Well, it's very simple. Is this, right off the bat, you can tell this is covalent because it has prefixes. Only covalents have prefixes. So what are the prefixes? Di, which means what?
2.
And hex means?
6.
So you got 2 carbons and 6 oxygens. Now look at your choices. Some people will try to pick that one for some reason. I don't know why. Moving on. Now, as we get down to the other ones, they're not so bad. I've memorized the mass of H2O just from, and you will too eventually. But all you got to do is find the formula mass, which is just actually add up the pieces. You got 2 hydrogens, each have 1.01, and then which is found right here. And then oxygen has a mass of 16 if you round it to do decimals. Never round to a whole number, by the way. So you add them together, 1.01 plus 1.1 plus 16, that's going to give us 0.02 AMU. Not 18, but 18.02. It's very important you keep those 2 decimals since we're dealing on the molecular level here. Blah, blah, blah. All right. Number 4, what is the formula mass of the following? All right, so you got calcium, and if you find calcium's mass, it is 40.08, and there's only one of these guys. Now here's the thing. How many oxygens do you have? 2. You have 2. Remember, this distributes. So you have 2 16s So 16 times 2 is going to be 32. I'm just going to go ahead and multiply them. And then 2 hydrogens. Well, 1.01 times 2. Now add them all together, and what you get? 74.10 AMU. Anybody get anything different?
No.
Okay.